The broadcast is now starting. All
Good
attendees are in
afternoon.
listen-only
Welcome to
mode.
Eccentric Mold Engineering's webinar. If you're here for adding undercuts and side actions without sacrificing speed to market, then you're in the right place. I'm Connie and I'll be your host for this session. A few things to cover before I turn over the webinar to our keynote speakers. This presentation is expected to last approximately 20 minutes. Q&A is included during the presentation, so feel free to submit your questions using the chat function located in the lower right-hand corner of the control panel. If we run out of time before all the questions are answered, we'll follow up by sending you an email containing the answers to those, as well as a recorded version of the webinar for reference. I'll now turn over our webinar to our keynote speakers, Darwin Rowe and Glenn Miller. Darwin and Glenn, please tell us a little bit about yourselves.
My name is Darwin. I've been building molds for 20 plus years, and I've been at Eccentric now for about a year, and I'm a senior project manager.
Hi everybody, I'm Glenn Miller. I'm a tooling engineer and project manager here at Eccentric. I've been a mold designer for about 25 years, and I've been working at Eccentric for about a year and a half. So let's get started. The name of this webinar is Adding Undercuts and Side Actions Without Sacrificing Speed to Market. Our agenda for today, what is an undercut? What are the purposes of including undercuts in your design? What are the requirements for an undercut? What are some of the undercut challenges you may face? Optimizing undercuts. And then we'll go through a summary and some of our tips moving forward. Number one, what is an undercut? Basically, an undercut is any indentation, protrusion, or feature that would prohibit the normal ejection of a part from an injection mold. Undercuts can be used to carry out complex forms in molding, such as an overmold or an insert molding process. Then those can be anything from a threaded insert or some other type of metal or material that the customer wants inside of their plastic part. An undercut feature is something that cannot be captured with just the normal open and close of the cavity and core.
A lot of times it's used like as a clip would
Correct.
be an undercut.
Purposes of undercuts, as Darwin noted, you can create any kind of interlocking snap or latch feature, which we have an example over on the right. This allows for any kind of clamshell or housing designs that can come together and snap and assemble together quickly without additional assembly features like screws and so forth. Undercuts can also help capture side holes, ports, any kind of opening, whether it be for wires or buttons or some sort of assembly area that another piece would go through. Undercuts can also help us capture vertical threads, as you can see by the image to the right, as well as barbed fittings, hoses, any type of feature that has something sliding over the top. These are typically used in medical devices. We'll look at undercut requirements. We've got a couple of examples here of a simple feature. The part in green, we have a hand load in the pink there. This is a simple manual hand load. You want to design your feature on your part that has enough space around it that would allow for the removal of this hand load without running into an obstruction or requiring some sort of twisting or distorting of the part. So you really want to maintain some space around your feature so that you can pull a hand load or a slide and create that. And you also want to make sure that any kind of hand load or slide feature is designed in such a way that it effectively shuts off. We use the term here pinch, so that the hand load and the cavity and the core all shut off very tight. This will maintain a nice clean seam, and it'll also reduce the potential for parting line flash. You want to make sure these things are fit together tightly, designed as simple as possible without a whole lot of extra features. And the main reason is so when the cavity and core come together and shut off on that, it's not holding the parting line open, and it keeps it nice and clean. We have some undercut challenges we'd like to talk about. Number one, non-drafted features and areas can be very difficult to remove, even with a slide or a hand load. In design, tool building, we always prefer that you obviously add draft anywhere you can to help this process. We have a area here that we say hand loads can be coated with nickel plating, Teflon plating, for any areas that you simply cannot add draft to. This will help the pull on that hand load so that it comes away without distorting the feature. Anything you can do draft-wise is definitely preferred.
Very helpful.
But we do understand that sometimes that you simply cannot add draft to certain areas, and then we have to approach those a little differently. Again, we can do some different things with the hand loads and the pulls to help that process and help that slide out easier. Material is also another thing that can affect the pull of a hand load or a slide. The harder the material, obviously, the less flex allowed as you're pulling that feature. A lot of glass materials, they're a little stiffer. They would require more draft. You definitely need to consider your material choice and your design and determine what's best for your application. Any part on a cosmetic or show surface that requires an undercut, you're going to have an extra parting line, a seam around that area to make sure we can pull that area. So that's something you need to consider when you're designing your part. If it's an area that is cosmetic, that's going to be a show for the consumer. You need to kind of gauge the importance of that undercut feature, that snap, whatever it is, and what you can get away with as far as a seam line, because there will be a seam
On your show surface.
on the show surface. So we can make that as tight as possible, but barring any flash, there still will be a seam line there. So it's definitely something to consider for cosmetic parts. This next slide has some examples here on how to optimize undercut features. Ultimately, you would prefer to design your part without an undercut, something that the tool is just a simple open and close tool. That's always your goal. Obviously, you can't always do that. First example is a very simple snap latch type of feature. On the bottom, it's in solid, and the little arrow shows that we would require a slide or some sort of pull. Preferably, if you can do it, the image on top shows a window has been added to that design, which will allow the mold designer to actually create a solid piece of steel in that area that comes up and creates that feature. And that simply is open and close right there. That doesn't require any type of slide or hand load. Again, with the center one, instead of a hole, if you can put a slot or a clearance, what you don't see here is this slot feature actually is drafted in a way that we can have cavity and core steel come up and mate and shut off on each other without actually having to have some sort of pull. Again, always preferable. We realize that you can't always do that, but that is a preferable method if it's a simple clearance hole or for an assembly of some sort. And again, on the far right, instead of the 2 slots on a vertical wall, you can simply extend that slot up to the point where you can actually reach in there with cavity or core steel and create that feature. That eliminates any need for a pull. Simpler design, less can go wrong. There's always issues with slides, handles, anything that can get damaged, or the maintenance on a seam line. All of that affects the overall look of your part.
And during molding, there'll be less hands on. It's more of an open and close.
Exactly.
Less risk of something being damaged.
So we'll just go through a quick summary for undercuts. Number one, you would like to leverage your features. Undercuts can capture and include interlocking snaps, latches, holes, ports. We talked about threads, barb fittings for hoses, medical devices, and also this next area here, coring out thick part sections. A lot of times a part will be designed with bosses, ribs, other features that can create sink. And a lot of times sink is not preferable, obviously, to the customer. Your best way of eliminating or minimizing sink is to go in there and we say core out any of the thick plastic areas, which simply means you add a hand load or a feature or slide that will eliminate the bulk of a thick wall section. And again, we can also use undercuts for threaded inserts, custom inserts that would be used in an overmold process. And again, inserts, any kind of metal or other material that the customer wants included in this component in one process. That's another way of using undercuts. For design requirements, the undercut really needs to have enough space around it so that the hand load or slide or pull has enough room to be extracted from the part easily without some sort of damage or stress put on the part. Always good to maintain the awareness around your feature that there will be some sort of action required there and it's going to need to move. Materials, again, the stiffer the material, it's very difficult to remove some of these features, especially in a no draft situation. So that's, again, something to be cognizant of when you're designing. Stiffer the material, the more difficult that is to remove. Optimizing your undercuts. Design in undercut features that are basically perpendicular to the line of draw, and that simply means you want this tool, if at all possible, to just be open and shut, cavity and core, forming your features. Anytime you can eliminate any need for a pull or any type of action, always simplifying that tool design is helpful. We obviously can add those things in, but again, something to be cognizant of as you're designing your parts. And just some of our tips when we're talking about undercut features. We have a nice little animation on there on the right that's simply showing an open and closed tool. That shows a side pull on a snap that is in solid. I think we looked at a slide before that showed a window added to that area that would allow for a piece of steel up through that would shut off, open and shut, and be able to form that without that side action that you see there. We also discussed reducing or eliminating when you can anything undercut wise on a show surface. because you're adding in seam lines for the cavity and core to shut off on the action, whether it be a hand load or a slide. So again, something to be cognizant of. If you can't have any of those type seam lines on your part, you need to think about that as you're designing these features in. And of course, draft is always your best friend. Anytime you can use extra draft on your part, that'll help facilitate the undercut removal. Again, we know that sometimes that's not possible, but you just need to be aware of that as your team is designing the part. Always need to think of how it's being molded, how it's going to come out of the tool. That's important. And then any type of part that requires overmolding, whether that be threaded inserts, those are very prevalent in projects we do for customers, as is any other type of material, whether it be a steel feature or maybe a circuit board, anything that needs to be molded into that part. You just need to consider what type of actions would be needed on that to form those parts.
Okay, we're going to open it up for your questions. We do have a few questions here from folks. So starting off for our speaker board here, which is more difficult, internal or external undercuts, and why?
Internal, because of the room you have to remove the pull or the hand load that creates the undercut.
Yeah, and as we said, I mean, if you can design in enough space around that feature so that this can be pulled easily, it's always the better way to go. I know there are a lot of times there's some tight spaces in part designs and you're limited, but you want to minimize any kind of ribs or any other features that would interfere with that function.
Okay, next question. Why do a manual action versus an auto action?
Well, a lot of times that comes down to your project itself. Hand loads are a simpler design. They're easier to maintain. It's just whether or not we're running a one-off prototype where you're not going to run a lot of production. It's kind of a by-case basis, right? I mean, it's are you running 10,000 pieces or are we running 50 pieces? A lot of times, as the tool maker and the tool designers will also look at how that affects our process with our molding team out there, and we may sometimes add action so that it's automatic simply for our production team.
And on a bigger run, an automatic would probably be better for speed for you to get your parts, because if someone's got to handle each part, it slows down the process time, which slows down you getting your parts.
Absolutely.
Okay, and the last question we have for today. What is the most challenging part of undercuts?
Well, that's a good question. I mean, it's all of these things. Designing a part that's functional for you, designing a part that has proper draft. All of these things need to be considered. The material that you use. It's really a case-by-case basis on what the feature is, if it's a simple snap or whole feature or things of that nature. There are challenges for every circumstance, obviously.
We're going to take one more question here. Is there a minimum size for a hand load? And how does the hand load affect the cost of a part?
We have some pretty small hand loads. Is there a minimum size? You probably don't want it much smaller than a 1/2 inch square. I mean, we do have some smaller, but they are harder to deal with and more difficult for the operator at the machine.
Right, you realize, somebody has to manually load this into the press. Anytime you have a very, very small hand load, I mean, It can get crushed. It can get placed wrong.
Even just dropped.
Dropped, yeah, lost. I mean, that doesn't happen very often, but if it's that small,
It is
you can lose track of these things at the molding, in the molding process. And during a 500-piece run, that's the last thing you want to do is lose your hand load. So, I mean, there isn't a minimum, but we like to maintain within reason a decent size. As Darwin said, I think half inch is a general rule of thumb for us, but we can go smaller than that.
And price-wise, I think that would just be somewhere in the quote. I can't answer that question off the top of my head.
Now, there is obviously a difference between, I'm talking price-wise on how this would be quoted if it was a manual hand load versus a automatic side action, a slide. That'll definitely affect the complexity of the design, the complexity of the mold, the time it takes to make the mold. So that would be affected in a quote. Sometimes we will quote them both ways for a customer and have them decide which way is more beneficial for their application. Yeah.
Okay, thank you for your questions today. We thank you for joining the webinar for us today. If you have any questions or interest in Eccentric products, please visit our website, social channels, or contact the number directly listed on our slide at 586-598-4636, sales@eccentricmold.com, or visit our website at eccentricmold.com. A recorded version of our presentation today will be posted on our website. We thank you for joining us today, and we hope you have a great day.
Thank you, everybody.